So dividing polynomials, the remainder theorem, and the factor theorem. So the long division process is as follows. Let me erase some of this stuff. We can walk through it to make sure we're all right. All right, so 5,867 divided by 11. The way you'll set it up, notice that what was being the divisor, or what you were dividing with, sits on the outside, and what you're dividing into goes under the divisional symbol. And so you ask yourself, how many times does 11 go into 5? It doesn't, but it goes into 58 5 times. 5 times 11 is 55. Subtract 58 minus 55 is 3. You bring down 6. Then you say, how many times does 11 go into 36? 3 times. 3 times 11 is 33. Subtract, and that'll be 37. How many times does 11 go into 37? 3. Once again, 3 times 11 is 33. Have a remainder of 4. And this is how you would set up your answer, 533, with 4 over what you were divided by, 4 over 11. So the only reason I went through that, and I'm pretty sure you guys are comfortable with that process, is because that's exactly how we will be dividing with our polynomials using long division. All right. Let me erase some of this stuff so we can walk through it. Just erase all this. All right, so we want to divide x squared plus 10x plus 21 by 11 plus 3. All right, so this is our setup. X plus 3 sitting on the outside, x squared plus 10x plus 21 on the inside. So the first thing you want to do is compare first terms in each, and you want to ask yourself what times x will give you x squared, or you can look at it this way. X squared divided by x is what? And that is going to be x. So that's what you will put up here, and you normally line that up with the same variable, same exponent of your variable. So now you take this x and multiply to each term out here. So x times x is x squared. X times 3 is 3x.
I have a question.
Mm-hmm.
Why would we not line the purple x on top up with the x squared?
Because what's going to happen is when I get to this, it'll, like when you line it up with the variable with the same exponent, it's going to tell us when we're done. So really,
Okay.
we only have one more variable term to get to, and then we know we'll be done. And you'll see when we finish it out. And that's a good question, because a lot of people do that. And it's fine to do it, because really this whole space is just yours. You know what I mean? So it wouldn't be wrong to do it. It's just that will give you a marker, and you'll know when you're done when you do it this way.
Okay,
Good
thank
question. Yep, not a problem. Good question, good question. So now remember, the next step in the process is to subtract. So that's what we're doing here. And now we need to be careful. A lot of people make this mistake. They will assign the negative to this first term, but they forget to give it to the second term back here. So it has to go to each term. That's why I put parentheses around each term. So x squared and x squared will cancel, because it's x squared minus x squared. Then we have 10x minus 3x, which will be 7x. And we bring down to 21. Now we're comparing first terms in each again. We're talking about x to 7x. How many times is 7? How many times is x going to 7x? And that's 7 times. Or what times x will give me 7x? and that's 7. So put that 7 right there. 7 times x is 7x. 7 times 3 is 21. Subtract. 7x minus 7x will cancel. Then 21 minus 21 will cancel as well. So our answer is just x plus 7. You probably just go into the green. All right. All right, questions before we go to the next one? All right. Once again, let me erase this stuff so we can walk through it. All right, so we're going to divide 4 minus 5x minus x squared plus 6x cubed by 3x minus 2. So first thing we notice is that our problem is written in ascending order instead of descending, and normally the progression is descending order. So I'm going to just flip around the terms. 6x cubed minus x squared minus 5x plus 4. All right. So compare first terms in each. How many times does 3x go into 6x cubed? Have it right here. That'll be 2x squared. Once again, I'm lining up my x squareds. Take this, multiply to each term out here. So 2x squared times 3x is going to be 6x cubed. I want purple here. 2x squared minus 2 is going to be 4. Times 2x squared times negative 2 will be negative 4x squared. Use subtraction. Don't forget negative 2 negative turns positive here. These cancel. So now I have negative x squared, positive 4x squared, which will be 3x squared. Bring down negative 5x. So how many times does 3x go into 3x squared? X times. All right. Once again, x times both of these. 3x squared minus 2x. These cancel. Don't forget, once again, negative 2 negative turns positive here. So that's negative 5x plus 2x. That result would be negative 3x. All right, comparing those first terms again. How many times does 3x go into negative 3x? And that'll be minus 1. So take that minus 1, multiply it to each term on the outside. That's going to be negative 3x minus, but nope, negative 1 times negative 2 is going to be plus 2. All right, once again, this minus sign is to each. These cancel. This is going to be a negative 2 now. 4 minus 2 is 2 as a remainder. All right, so before we finish it off, questions on what we did?
I don't have a question, but could we just stay here for 1 second? I'm still coughing it down.
Yes.
Okay.
And while she's finishing it up, so we see how we would actually set up our answer here. Take the 2x squared plus x minus 1. And then we have our remainder of 2. We place that over what we were dividing by, which was 3x minus 2. Answer.
So I do have a question. When we have the negative 3x plus 4, like we bring the 4 down, are we looking to see what makes the 3x?
Yes, so it's always about, erase, I'll put it back, of course. It's always about comparing this term to this term.
Okay.
And so you say, how many times, and that's what I have right here. How many times does 3x go into negative 3x? And that's negative 1.
Okay.
Yeah. So let me go ahead and put that back. There we go.
And so every time we go to subtract, we'll have to distribute the negative sign?
Yes.
Okay. And then on our answer, why did we put the 2 over the 3x minus 2?
That's your remainder.
Oh, okay.
And so you always place that remainder over whatever you were dividing by.
Okay.
Yeah.
Okay, I got it now.
All right, not a problem. And just going back here to our original setup, that's the same thing that happens here with just the regular long division, just regular numbers. Our 4 was the remainder and the 11 is what we were dividing by. And so we were actually mimicking that same process. Okay. Hold up. Okay. Should put some type of. All right. So let me erase this and I'll put it back. So we have here x to the 5th plus x cubed minus 2 over x minus 1. So each one of our problems we had up to this point had our terms going in descending order and not skipping the number. In other words, if we start off with x to the 5th, you would start x to the 4th, then x cubed, then x squared, and so on. So this one is actually missing terms. You see that we're missing x to the 4th, missing x squared, and really x to the 1st power as well. So we need placeholders. All right, so let me erase. All right, so we got x minus 1, and we're trying to divide that into x to the 5th plus 0x to the 4th plus x cubed plus 0x squared plus 0x minus 2. So we use these placeholders to help us in our progression as we step through the long division process. So they help us. They don't carry any value. 0 times anything is still going to be 0. But once again, this helps us step through the long division process. All right. So once again, you compare first terms. You say what times x to the 5th will, what times x will give me x to the 5th, and that's going to be x to the 4th. So x to the 4th times both of those terms on the outside. X to the 5th minus x to the 4th. All right. distribute that negative. This one turns positive. And this one cancels. So 0 plus x to the fourth is just x to the fourth. Bring down x cubed. Compare first terms of each. What times x will give me x to the fourth? X cubed. That'd be x to the fourth minus x to the fourth, x to the third. All right, so now x cubed plus x cubed, that's 2x cubed. Bring down 0x squared. So what times x will give us 2x cubed? That'll be 2x squared. And once again, you notice how this is helping us keep track because everything's lining up. So that'd be 2x cubed minus 2x squared. Once again, distribute a negative. This turns positive. 0 plus 2 is 2. So that'd be 2x squared. Once again, bring down your term. That'll be 0x. All right, so what times, yeah, there we go, give us some more room. What times x will give us 2x squared? And that'll be 2x. Distribute. It'll be 2x. Bring down negative 2. And what times x will give us 2x? That'll just be 2. So 2 times x is 2x. 2 times negative 1 is 2. Once again, distribute that negative. I'll do it for my parentheses. Hold up. Distribute. This is positive. And really, we see all of them cancel, giving us a remainder of 0. Yeah. So this is the answer here. So let me see if I can make it smaller. Okay, take the whole thing. All right, make sure we're okay. All right, any questions? Everybody good? Let's scroll up. All right. All right. So the next one, synthetic division. Now we only can use this when the divisor is in the form of x minus c. So in other words, when you look at x, the exponent on it is 1, and the coefficient, the number in front of it, is 1. So that's the only form that can be used as far for the synthetic division. So if you look at this first one right here, we can use the synthetic division because it's x plus 2. This second one, we cannot use synthetic division because notice we have x squared in the denominator. And then in that third one, we cannot use synthetic division because you have 2 sitting in front of x. All right, so we're going to talk about it in a second, like how you do it if you haven't done it before, but just let you know what you need to look for. If there's anything in front of x, or there's an exponent on your x other than 1, then you cannot do synthetic division. All right. All right, can I scroll up? All right, so let's go about using synthetic division. So we have x minus 3, and we want to divide that into x cubed plus 4x squared minus 5x plus 5. So if you notice the note here, the first thing we want to do is use the opposite sign in this little box right here. Let me erase this stuff. So this is how we'll set it up. We use opposite sign in the little box, and then we use all of our coefficients. So notice we use 1, 4, -5, and 5. All right. Questions on the setup? All right. So bring down the 1. All right. Then we're going to multiply this 3 times the 1 and bring it up here. So that'll be 3. And then we're going to add these together. That'll be 7. And then we'll keep that same pattern. 3 times 7 going to be 21. Add these together. That'll be 16. 3 times 16 is 48. Add them together. It's going to be 53. And that last number is always your remainder. Of course, that means it can be 0 sometimes because you have a 0 remainder. So now before we finish off the problem, question with the process. First thing you do is drop down this first number right here. So in this case, it was 1. Drop down to 1. Then we take the number 3, that number, whatever number sitting in that box, and you multiply it times the number you just dropped, and you bring it up to the next number in the sequence. Add those 2 numbers together, then that'll be the next number that will be down bottom, and repeat the steps of multiplying it 3 times that number, taking it up top to the next number in the sequence, add them together, and like I say, continue that pattern until you get to the end. And then to get your final answer, you start with the exponent less than, one exponent. Start with 1 exponent less than the original polynomial. So the original was x cubed, So we start with x squared. And we use all of these coefficients as our coefficients. So there's 1x squared, 7x plus 16 plus 53 over x minus 3. That's the remainder over what we were dividing by. All right, questions. Once again, this process can only be used if you only have one in front of your divisor as far as your variable and one as the exponent. So the next one, so we have 5x cubed plus 6x plus 8. And we want to divide that by x plus 2. So first thing we recognize that we're missing a term. We're missing x squared. And then when we go to set up our problem, we want to use the opposite sign of that plus 2. So we use a negative 2. All right, let me erase. So notice how we set this up. We're going to use the 5, 6, and 8, but we have a missing term. So we put that 0 here for our missing term. Problems or questions with the setup? All right, bring down 5. I think I was called this red, right? And then, like I said, we're going to take this negative 2 and multiply times the 5. So negative 2 times 5 is going to be negative 10. Add those together. That's going to be negative 10. Negative 2 times negative 10. Positive 20. Add these together. 26. Then negative 2 times 26 is going to be 52. Negative 52. Add them together. Negative 44. And there's our answer. Once again, you start off one less exponent than what you had originally. We had x to the third power. So we're starting off with x to the second power. So that's 5x squared minus 10x plus 26 minus 44 over x plus 2. Or we could have written it with the minus sign up here with the negative 4. All right. Questions. Scroll up. All right. So we have the remainder theorem. If a polynomial f of x is divided by x minus c, then the remainder is f of c. So in other words, you can find a remainder by taking, this number right here and plugging it into your function. Notice it's the opposite sign. We have a minus x minus c here. But when you plug in positive c, that's when you will get your remainder. So if we were to go back, and then we'll go back down, if I took -2 and plug it into this function right here, then I should get out -44. That's what the remainder theorem states. All right, so if they give us the function f of x is equal to x cubed minus 4x squared plus 5x plus 3, use the remainder theorem to find f of 2. All right, so notice they gave us f of 2. So whenever they give it to us like this, then we will go ahead and use the 2 that they give us. Now, remember what they did before is they would give us our value through this algebraic expression. So if I have x minus 2, that means that corresponds to f of 2, and this corresponds to f negative 2. So that's what we're talking about when you would use the opposite sign. If it's with x, like this, then you would use the opposite sign. But if they give it to you like this, then you would just go ahead and use the number that they give you. So just be, careful with how they give you the information. Once again, going back here, they gave us x plus 2, so that's why we use the -2 right here. All right. But in this one, they gave us f of 2, so that is the number that we're going to be using, this 2 right here. All right. So we can walk through it. So we have 2 in our box, and we got 1, -4, 5, and 3 as our coefficients. First move is to bring down 1. All right. 2 times 1 is 2. Add them together gives us -2. 2 times -2 is -4. 5 plus -4 is 1. 2 times 1 is 2. 3 plus 2 is 5. So this is our remainder. Now, if we've done this correctly, what it says is that if I were to take this 2 and plug it into the function, I should get out 5, according to the remainder theorem. So that's what I did right here. So 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. 2 cubed is 8. 2 squared is 4. 4 times 4 is 16. So 8 minus 16 plus 10 plus 3 gives us 5. So that's all the remainder theorem is saying, is that you would take that value, plug it into your function, that will let you know what your remainder will be if you were to divide by that expression.
I'm sorry. So why are we trying to equal 5?
Well, it's not necessarily about equaling 5 necessarily. It's about the fact that when I performed the synthetic division, I got 5 as my remainder. And the remainder theorem says that if I were to take this number and plug it into the actual function itself, I should get the remainder. So when I plug it in, I got 5. So it's just matching up, just proving that the remainder theorem works.
Okay.
Yep. So in other words, if I had got 15 right here, then I should expect to get 15 down here. All right. Okay. Before I go up, make sure everybody's okay. And so the reason why this is important is what we're about to segue into next. You know, knowing your remainder will let you know, if you have a factor or not, or if you have a solution or not. Because remember, when you talk about solutions, when you plug that number into your function, you should get 0. And so solution, 3 names for a solution. You have solution, 0, and root. Well, the reason why it's called 0 is because when you plug it in, you get 0 for the remainder. Or when you divide it, you get 0. So that's why they're called zeros as well. So if this was a factor of that function, we would have had 0 in both cases instead of 5. All right. So factor theorem. Let f of x be a polynomial. If f of c is equal to 0, then x minus c is a factor of f of x. If x minus c is a factor of x, then f of c is 0. And that's basically what I was just saying. And I'll show you in a second as, make sure we're clear on what a factor is. If it is a factor, then 0 would have been the case for both of those results. Whether it been synthetic division or plugging in the value, you would have gotten 0. Like I said, I'll give you a chance to write that, and then we'll look at what a factor is. All right. So if you were to look at this example here in the green, x squared plus 7x plus 10 equal to 0. If I were to factor that out, or factor that completely, x plus 5 and x plus 2 would be the factors of x squared plus 7x plus 10. So that's what we're talking about, factors. And so if I were to solve that, I would get x equal to -5 and x equal to -2. And we know that those are solutions. And when you plug your solutions into your equation, and this is just an example of that, you get 0. And so once again, that's just another reason why they are called zeros as well. So solutions and zeros are the same thing. Synonymous. All right, so let's look at this example. I think this is the last, oh no, we got 2, okay. So, wants to solve the equation. And I'm gonna erase this stuff. I'll put it back. So solve the equation. 2x cubed minus 3x squared minus 11x plus 6 is equal to 0. It wants to solve it given that 3 is a 0. So if 3 is a 0, that means 3 is a solution. And that also, let me see, did I write that? No, I didn't write it. The fact that I have 3 right here lets us know that we should get 3 solutions. So we already know one of them, we just need to find the other 2. All right. Question, scroll up. So we can use synthetic division to break down the function. Now, we know that 3 is a 0. And if I were to erase all of this, I know that 3 is a 0 of this function. If that's the case, then I automatically know that 0 goes right here. And also -6 goes right here. Because I know that 3 is a 0 of this function, and my result has to be 0 for a synthetic division process. So if I do not get 0, then somewhere I went wrong because the problem told me that 3 is a 0. So it just goes back to using the directions to your benefit. So let me go ahead and put the stuff back. All right. So going through the process, we have 2, you bring your 2 down. 3 times 2 is 6. 6 plus -3 is +3. 3 times 3 is 9. You -11 plus 9 give you -2. 3 times -2 is -6. 6 plus that -6 will give you 0 as a remainder. Once again, we knew that was supposed to occur because we know that 3 was a 0 of the function. All right. Questions? All right. So we have 2, 3, and -2 as our coefficients. Remember, you start off 1 degree less than what you had originally. We were x cubed, so now we're here at x squared. So we can solve the remaining equation now. 2x squared plus 3x minus 2. Set it equal to 0. Factor it. That'll give us 2x minus 1 times x plus 2. Set each part equal to 0. And solve. So that's x equal to 1/2 and x equal to -2. And also don't forget that 3 was a solution as well. So they're going to ask you for all solutions. If you leave the 3 out that they gave you, they will mark it wrong, or they might take all points. Either way, 3 is a part of your solution set, and you got to make sure you include that. All right, questions? Any questions? All right, can I scroll up? All right, so let's do it at least one more time. We have, we want to solve the equation 15x cubed plus 14x squared minus 3x minus 2 equal to 0, given that -1 is a 0. So we're talking about setup. -1 goes here. 15, 14, -3, and -2 are our coefficients. Don't forget, since -1 is a 0, that means 2 and 0 should be right here, as you go throughout the process. So in other words, if you don't get 0 as a result, somewhere we went wrong. So bring down 15. -1 times 15 is -15. 14 plus negative 15 is negative 1. Negative 1 times negative 1 is positive 1. Then negative 3 plus 1 is negative 2. Negative 1 times negative 2 is positive 2. Add those together, you get 0. All right. So once again, start off with 1 degree less than what you originally had. We're starting with x cubed. We had x cubed, so now we're going to start this part of the process with x squared. So 15x squared minus x minus 2 is equal to 0. Remember, we're getting those numbers from right here. 15, negative 1, and negative 2. We can factor that to 5x minus 2 times 3x plus 1. Set each part equal to 0 and solve. So you get 2 over 5, negative 1 over 3, and negative 1, which was the original one that it gave. And those will be your solutions. All right, questions. All right, is everybody good? All right, so that's 3.3. Next class, we'll be looking to get into 3.4. Like I said, take advantage of the fact that we will not have class on Wednesday, but I want you guys to get the opportunity or have the opportunity to get caught up on chapter 1 and chapter 2's work so that I can give you a decent grade or the grade that you desire on for your midterm. Any questions, concerns, comments before we go? So after today, I won't see you Monday. I will see you the following Monday. All right, because next week is spring break. All right. Anything else? Everybody else? Oh, always feel free to email me if you have a question or anything. And we'll move along from there. All right. So you guys have a good one. Be safe. Like I said, don't hesitate to email me if you have a question. And I'll see you next class.
Thank you.
Thank you. You have a good one.